Okay, so here is a video of the second day of the limit test review. Your test is just gonna say find the limit. So you have to pick the most efficient method so that you don't run out of time on the test. So for any problem that says from the right or from the left, like number 1, I would look at my graph. So here's my calculator. You have to be careful anytime you type in a rational function, which is a fraction, you have to put parentheses around your numerator and denominator if you have more than one term, like this binomial. So I'm gonna graph it. If your window is messed up, hit zoom 6, which is a nice 10 by 10 window. So this is from the right. So as I approach 3 from the right, it goes up to infinity. Number 2, it says 0 from both sides. Well, I can't plug in 0 because that gives me undefined in the denominator. So you can look at a graph or you can make a table of values. So to the right of 0, to the left of 0. So I'm gonna plug in the absolute value. To get absolute value, you hit the math button, arrow over to num, and choice 1 is ABS for absolute value. And then if I go to my table, I have all the integer values here. So I have to hit second window, change independent to ask, and then when I go to my table, it's blank. So I can type in the values I had written in my table. So -1, -1, 1, 1. So from the right and from the left, these are different. So the limit does not exist. If you look at the graph, we could see that as well. From the left is -1 and from the right is +1. They're different, so it does not exist. So now, number 3, it says 0 from the right. So I'm gonna look at the graph again. So we have a semicircle. So here's 0. So as we approach from the right, if I hit trace 0, enter, it tells me, sorry, the bell. It tells me the y value is 5. So 5. That's one where substitution would work as well. You could have just plugged in 0. But now let's look. Number 4 is 5 from the left. So here's +5. From the left is 0. If I hit trace 5, I can see the y value is 0. You have to be careful though. Let's say this problem said 5 from the right. There is no graph to the right of 5, so this limit would not exist because there's no graph to the right. For number 5, if we plug -1 into the denominator, we get 0. You can't divide by 0. So I'm gonna factor and see if I can eliminate a factor so that I could then plug in -1. So what multiplies to -4, that adds to -3. What multiplies to 3, that adds to 4. So very nicely, the factor that would make this undefined gets eliminated. So now I can plug in -1, and I get -5/2. 6 is to infinity. So that's the kind of problem where we look at the end behavior. The rules we wrote on page 14 in your packet, go back and look at that. If you were absent, make sure to get them off Drive or from a friend. So I see that the numerator exponent is smaller than the denominator exponent, and that means the end behavior will be 0. For 7, I can't plug in 0, I can't factor or simplify, so let's look at the graph. So as we approach 0 from both sides, both pieces go to infinity. Number 8 is another problem with end behavior because of the infinity, and I'm going to look for my exponents, and since they're the same, we divide the leading coefficients. So that's the 1 and the 3 for our answer. For 9, I can plug in 3. Now you can cube root a negative 8. Which is a 1/3 exponent, so that's negative 2. So our answer is negative 3/2. For 10, because it says from the right, I'm gonna look at the graph. So math, num, ABS for absolute value. You have to put parentheses around the denominator of x plus 6. So here's negative 6. From the right is positive 1. All right, and the last two, 11 and 12. We want to make them continuous, so I'm going to set the pieces of the piecewise function equal. And I want them to be equal at the x value they overlap at. So I'm going to plug in 1 for every x. And solve to get a is negative 2. 12 is a little more work. I have some separate paper for that. Because there's 2 pieces to line up. So we're going to line up the 2 equal to ax plus b. And I want those to be lined up when x is 1. Then we have the bottom 2 pieces. And I want those to line up when x is 5. So now you have a choice in solving. I will do both ways since it's a review video. My preferred way is the elimination method. I line up my 2 equations and I want to eliminate a variable by adding or subtracting the equations together. So if we subtract this bottom equation, the b's will eliminate to 0. So 2 minus negative 2, 1 minus 5. So negative 1 is a. And then I'll choose this equation to plug it back into. So 3 is b. The other method is substitution. And from your 2 equations, one of them we want to we want to isolate a variable. So I'll pick this equation and I'm going to isolate b by subtracting a to the left. Then I can substitute that in for this b. So combining my like terms, on this side we have 4a, move the 2 over here. We get negative 1 is a, and then it's easiest to plug that back in here, and we get 3 is b. Same answers as same answers as the other way. So I don't know if that was off the camera view when I did it, I'm sorry. So this negative 1 I plugged back in for this a and got 3.